So welcome back from lunch break. From an organizer's perspective, again, I'm sharing a bit of anecdotes and let you look into the head of a conference organizer. At Troopers, we don't pay any speaker honorariums, not even for the keynote, as we want people to come here for Troopers, not because this is a paid gig. And well, obviously all speakers come here as they want to be here. But then there are some where you feel they are full of energy and they are excited. They are like, oh, I want to be at Troopers. I came up with a submission. And you can read a lot of detail went into that, a lot of energy. And this is one of the, I'm happy to see you finally in Heidelberg. Andrew,
thank you.
Over to you.
Thank you. Yeah, no, it's great to be here. You know, for me, this is the creme de la creme of identity and AD security. Standing on the stage and recognizing all the people that have come before me, you know, Will, Lee, you know, Sean Metcalf. I mean, you can go, the list goes on. Michaels was speaking today. I mean, dozens of people, it's countless. So to be here is absolutely incredible. I didn't think this talk would get recognized or even accepted, but you know, here we are, and I just cannot wait to share all this with you. So what we're going to do is we're going to talk about LDAP and my journey through LDAP and trying to understand just the logs on how LDAP works. This is a detection engineer's perspective. There will be a lot of purple teaming going into this. So we'll execute some tools, we'll check out the logs, and we'll see, you know, what the detection possibilities could be. Really, it started with an entire just thought is, how could I detect tradecraft around Active Directory? And I've done a lot of work in Kerberos, and we'll get into that in the next slide. But really, being at an MDR at Huntress Labs, we're baselining against 5 million endpoints and trying to roll out detections across all 5 million. There's no baseline. So it's not that even, you know, someone uses Java, someone uses Python. We find people that use Ruby. There's no baseline whatsoever. The only baseline is against 5 million. So going through there's 9 posts. I just had one released yesterday, which is part of it, and we have some that has been saved specifically for Troopers. So again, I'm Andrew Schwartz. I'm a principal detection engineer currently at Huntress. My big thing is around purple teaming, AD tradecraft especially. I've done a lot of Kerberos research. You might have seen, especially with my counterpart, Charlie Clark, Exploit PH, we did Diamond Ticket. I've done some work around DACL-based attacks with Megan Nelson prior at TrustedSec. I've just got into DMSA, where I did a post with Yuval. And just some, you know, personal info about me. Please don't walk out the room or give me questions or give me a tough time, but I am a Tottenham Hotspur supporter. I do like chess and old fashions and boulevardiers. So that's a little bit about me in a nutshell. Okay, so generally, I've written dozens of detections, and you know, some make it, some definitely don't make it. Some, you know, will be in our experimental phase, and then they'll just sit there and they'll cook, and they'll never see the light of day. But again, what really happened was, you know, Huntress came to me and said, look, we want to get into more Active Directory-based attacks. I figured LDAP was the perfect place to start. And I'll show you why in the next couple slides. And I figured I want to start with looking into the protocol and going from there instead of just, you know, you'll see we'll look at some tools and some of their signatures, but really I wanted to really get into just LDAP as a whole. So again, we're looking at 5 million endpoints. All right, so every rule has to go into that. Some of the rules have been tested and are currently in our production set. Some are in my lab, but you know what we'll do is we'll get into this. And we've had some failures along the way of what works, what doesn't work. You'll see that. I had some in packet rules, and I was like, why is this not firing? And it might have been below a threshold, which we'll get into. What I hope people really leave with is I hope they leave with more of an understanding from the detection engineering perspective, if you're running these tools as a pen tester or red teamer, I hope you gain some level of OPSEC. If you're a sysadmin, I hope you understand the power of LDAP logging, even though Microsoft considers it a diagnostic log and not a primary event log, which we'll also get into. And if you're a blue teamer or a purple teamer, really understand some of the attacker-based tradecraft. So again, just some numbers. We're going to look at a whole gambit of tools, right? We're going to look at Bloodhound, Sharphound. We're going to look at Packet. We're going to get into SOAPhound and ADWS. We're going to get into LDAP nom nom using CLDAP. And lastly, we'll get into Maladaptive, which was done by Daniel Rees a couple years ago. And they haven't really released some of the offensive side, but they did release the detection side. And I'll show you some of my research there. But again, this is sort of the gambit and litany of tools that we're going to cover. So where are we in terms of when we're looking at this talk in LDAP tradecraft? We are at number 1. This is a different take sort of on the attacker's attack defense kill chain by InfoSec Ninja. We're at the discovery model. This talk is going to talk about discovery. We're not looking at anything else, which is kind of an interesting take, especially for me, because generally, at first, we've always prioritized those persistence, those lateral movements, those credential access techniques. That's what the attacker has to do. The defender knows the attacker has to do something. They land on the box. They have to then do something. They're going to sit there indefinitely, but what is that really going to do? So I wanted, again, an alternate take on this, and I really wanted to focus on discovery. So we'll look at LDAP and ADWS as well as CLDAP. This is where this talk lives. So 3 arcs, 9 parts, right? This is what's going to happen, and our end thesis, right? Event 1644, the diagnostic log, is alone, but it's not enough. So you need the forest, not the tree. So again, 3 arcs. We're going to start with signature-based detection, blind spots, and going beyond signatures. We could have obfuscation, LDAP, and LDAP mon kind of in here, but really I wanted it to be on its own at the end, because you'll see some correlation, some other things. But again, this is sort of how this presentation is going to flow and what we're going to get into. All right, so before anything else, we have to enable event ID 1644. That is the main log, right? So again, this is a diagnostic log. So what we can do is we can change that via the registry key. We can enable that, and then we'll start to generate our logs, right? Is there going to be some CPU and volume caveats? Yes, probably. We've been rolling this out to a lot of our customers. We've not had a lot of CPU spikes or anything like that. That's not to say, you never say never with Microsoft, something could happen. But again, Microsoft considers this a diagnostic log. They don't consider it a real security event log, right? It's not in that security event channel. It's in its own different channel. But what we'll do is we're going to enable our logs. That's the most important thing. So what we'll do is we'll enable max LDAP logging. I've already sacrificed the live demo gods. Let's do it live. So I have here a box just sitting in Azure. It's my own personal lab. Right now, and just also so you know, this lab is going to be more take on the Sopranos theme. So if any Sopranos fans here, versus some of the slides you'll see will have a different domain, which is Marvel. So Marvel's my home lab, Sopranos here. So what we'll do is we'll just do a / enable max LDAP logging. And so yes, I know I'm in a lab. Please, consider this just as is. But what we're going to do is enable all the registry keys. We can, what we'll see is you'll get all sorts of events now with a variety of LDAP logs. Some of these other ones are actually going to come into play, which you'll see, maybe with some of our internal LDAP operations. But, just as, again, for this lab, we want to enable everything. And then we'll get into the thresholds and all of that. And I do have, I had a couple logs generated. So what we can do is we can just do cycle through. And just to see that we're getting logs, right? So I went ahead and I prepped just to make sure we're getting logs. So this is a little bit of a debug script that I had. Yeah, did I have Claude code it? Yes, I did. But it wanted it to help me understand the logging better. So I wanted to see, what's being parsed, what's available. And so now I have an idea that we're being fully logged, right? So this is just sort of my own personal health check. So again, we've enabled our 1644 from my DC. That's what we want to do right now. And one of the other big takeaways is please read every column. Okay? It's very easy to look at a single column, especially as a detection engineer, and most often we'll say, what is the filter? Did they do, service principal name equals star on user accounts for only users, and as an indicator of curb roasting. But what we really need you to do, or what I need you all to do, is look at the client, look at your starting node, your filter, and we're going to get into all of these, right? And that's the biggest thing, because each one of these we can build detectors around and use effectively. So let's get into OID transformations. So this is our first part of where we're talking about. What I wanted to do was start simple and look at just a common in-packet tradecraft, right? So in the in-packet code, if you go in, you search GitHub with Control F, you go down to the filter. What you'll do is you'll see these OID numbers. Now, what's very interesting about these is, especially if you write logs around this, you'll never get anything. Your alerts will never go off. And I've learned that the hard way. Why is that? Because what's happening is a transformation in data is occurring, okay? So what the client sends, what the attacker sends, is not what your domain controller is gonna send or see or log, right? You're going to have this transformation between OIDs. So this is the first sort of gotcha. We have to write rules against the log form, not right now what's on the wire. Yes, we have to know both, but it's more important right now is what we want to do is we need to catch around this OID transformation.
Is this even true for the XML view? I mean, when you look at the event viewer, then
I believe we can get into that and confirm. But mainly the big thing is we're logging when the logs are being captured and into a SIM or forwarded into the SIM, they might not be pulling to XML directly, they might be pulling more from the security log. It just depends on where you're pulling from, right? And how you're parsing. But it's a good question. So your transformations, right? So there's different OIDs, right? And each one is going to be, something different is going to happen. So what we got to do is we got to work Sigma rules around these OIDs. Okay. So now what we want to next get into is some white space and formatting. And again, we're just in the signature phase. We haven't even gotten to behavior. We haven't gotten to really anything crazy, right? You can run a query in LDAP 7 of 50 ways I've found. And each really one of these, the question is, how does the defender take into this account, right, of this white space? So what you see here is, right, you have no white space, some white space, maybe double white space, and you go on, right? And so this is very important as well, is that, what do you do as the attacker, or as the defender, rather? So again, what the client sends, the domain controller is going to say, no, we're going to transform, right? So the data is being transformed. And so now you really need that regex, right? This is where regex takes into place. Regex is very powerful, especially with Sigma. They've done a lot of work there, which is great. But your regex parsing needs to take into account for a lot of the white spacing. So you want to normalize the match. Okay. Next, right? We're going now. I'm going to get further in. This was probably one of my favorites that I got into as a defender, as a blue teamer, is SD flags, right? So looking into the logs, I was like, oh, SD flags, and this was very, very interesting for me. This is one of the tells that Bloodhound or possible enumeration tool is really taking into effect. So we've gone through, right, the OIDs, we've gone through the white space, but this is really important, right? It tells which part of the NT security descriptor is being read, right? The owner, the group, the DACL, the SACL. So Sharphound might use, or will use OX4 and OX5. SOAPy and SOAPhound both ask for OX7. And this is what you'll see in the next reason is why this is so important. This tells why the attacker wants NT security descriptor, right? So what's inside of it, right? So we know the owner, who owns the object, we know the group, the primary group, but the DACL tells who can do what, right? And the SACL is the audit. But why they want it, right? So they want it because they want to find, those, who has over what, 80 self, RBCD, generic all. Again, that's why it's very important. And again, we're looking at, and this will be very important and when we get into some of the later slides, we're really looking at Bloodhound or the tools LDAP collection. We're not looking at the session collection. We're looking at the entire domain controller side. So what we'll then need to do is we can get a little bit more tailored, a bit more tightly scoped by including these SD flags into our detections. And that really can boast the efficacy of those base detections. SOAPhound. So we got to look at all the tools, right, and all the paths. SOAPhound was very interesting to look at. When you look at the source code, SOAPhound has this very lovely, you could call it an IOC, that a blue teamer or purple teamer like myself might say, oh man, that's interesting. I could totally write a detector around that. Well, again, the transformation is occurring on the domain controller side. So that entry there does not exist in the Microsoft documentation. So what happens? The domain controller transforms it into the log, becoming bang false. And again, this is where the blue teamer or the detection engineer can get really tripped up if they're not understanding how these transformations are taking place from the client side to the domain controller side. Okay, so what we want to do is we really want to stop hunting names, such as SOAPhound, maybe in a filter. We want to really start hunting the behavior, right, where it can be false or non-existent. We want to also understand, our bitwise operators as well as those transformations happen. So the same moment, the attacker view versus the DC view. This is just, again, just some data that I've put together, and we're going to actually kind of run it. We'll run it in our lab just a second. But what we'll see is on the attacker side, they'll gather all the AD data, but what the defender sees is totally different. So let's do a little bit of a live demo right now. Just before we do everything, we are logging. Let's clear our filter. Let's clear our filter. Let's clear our logs. And that obviously did not like that because you have to give it the lovely no lapse, I believe. It's one of those gotchas. There you go. I always forget about that with SOAPhound. But as you can see, I had the cache built. So with SOAPhound, you got to build the cache ahead of time. I went ahead and did that. I didn't want to bore you all as I do that. So I was just able now to run it, again, with no errors. You can see here the LDAP query. We see that our SOAPhound equals star there, and we can get all of our data. So now we'll refresh our logs. And right there, we'll go into a false pattern. We can see our false. Oh, live demo, right? Double clicking. It would be better if I used the mouse. So right there is our false, right, as everyone can see. Now, as you'll see in the next slide, we have a little bit of a problem with this. : 1, we lost our attribution. So we don't know, we know the user, but we don't know where they're coming from, right? So that's a little bit of a problem with ADWS, and we're going to get into that and how we solve that, and let's restore how we restore attribution. So getting into the ADWS, right, conundrum, our second part of the arc. I was looking into an incident, and this is true. They ran a simple get AD user minimal obfuscation with k-spacing, and what had happened? They pulled back all the usernames. And I was honestly just beside myself because it's a very, very simple, rudimentary tradecraft to run PowerShell and run get AD user and not to be able to be detected. And after spending all that time on that previous arc of what you saw, none of my detectors fired. Why is that? Because PowerShell, like SOAPy, like SOAPHound, take an alternate approach. Like Ping Castle, take an alternate approach. They traverse Active Directory Web Services over 9389, which then touches LDAP, which then gets into event 1644. So what happens on the defender side? : 1, which is generally our loopback address. So we've now officially lost attribution, right? We've lost that source IP attribution, which some people will say it's a little bit more OPSEC safe for the attacker. Okay, possibly. So I was in the Bloodhound Slack group, phenomenal, phenomenal resource, and I noticed a conversation that was taking place. Someone asked which was the best way to perform OPSEC AD enumeration, ADSI or ADWS, and someone chimed in responding ADWS, specifically because the service talks to LDAP on loopback, and there's no way to correlate the originating host. Very, very difficult. My partner, well, Charlie Clark, a good friend of mine, who I've done a lot of research with, and he knows me very well, where we've traded attacker and defender ideas, chimed in and said, well, what about a network event? What about 5156? And right away, I knew that he was onto something. So I said, challenge accepted. The data has always been there, but no one was correlating it. So how do we restore our client-side attacker address? The key is correlating with 5156. So as a defender, we got to chain sometimes multiple events together. And what we can do is we can see that 5156 from our source IP will hit 9389, which is always consistent, to our domain controller. There'll be some more information, but it's obviously cut out for abbreviation. You'll see it in the video with that process, with the ADWS process. And then what happens, right? It's eventually going to hit the loopback. But there's a middle part here that's not yet that wasn't so simple, right? It wasn't so simple of how to chain. How do you get from 1 all the way down to 3? So the one video I have recorded. We're going to have this get ADWS dual. What we're going to do is we're going to run it on our domain controller, just to start. Just a little bit of fun fact: there is some on this video. There is some there is some what was I going to say? Sort of Huntress made a K-pop Demon Hunter song. My daughter loves it, but I'm not going to bore you all with that. I don't think you all want to hear K-pop right now. But yeah, so let's run it. So we're going to run it in monitor mode. Got a little blurry there. Why is it blurry? Shouldn't be blurry. If it gets blurry, we have a backup copy. This one I have on YouTube. And we're blurry for some reason. Why is that? Well, it's okay. Let's pull up a backup copy. It's funny that the recorded demo isn't working, but the live demos are. Okay. Let me share my screen now. Back to it. Okay. Fast forward just a little bit. Run in monitor mode. So now we're pulling, right, we're pulling our logs. And we're going to look for 5156 chaining to 1644. Pull interval about 5 seconds. Let's go over to our attacker box. This was in my Marvel lab. We're going to just run SOAPy, which is a different tool. And we're just going to enumerate, let's just say, all the users. Just as a regular user, anyone can do this, right? And here you can see that we've basically pulled back everything, right? So going through it, we'll scroll. You can see all the attributes. You can see NT security descriptor. This is exactly what the attacker sees. Just fast forward just a little bit. Yep, so he's pulled it back. And what happens, right? So what happens is we're going to send a 5156. We're actually going to use 1138, which was a different log, but we're going to use it as an intermediary, right? So we can correlate on our port numbers, right? And then we're going to use that to get, we're going to use that 5156 to here, and from there we're going to use the port numbers to restore our attribution. So you can see our alert already came in. It's a little hard to see, but we have ACL enumeration as part of an alert, as well as full SD pulling, which is just a couple of indicators. But the main takeaway, right, is that now we've restored our client IP address of the attacker in our lab, which was that 10.11.13 box. So to really summarize this, right, and to summarize this part, the biggest thing in takeawaying is correlation is possible. The data has always been there, but no one was doing it. So I'm glad that that demo got working. And we'll restore our, sorry, not that. My presenter notes. Technical difficulties. That's all right, we'll just do this. Okay, good, let's restore. Great. And just to, I know it was kind of small, but I want to have it on screen so everyone could see it. This was sort of a sample alert that I had in my lab that was captured, and there you can see all the information with the chaining. And you can add your own indicators. So that is really taking us into multi-event correlation, right? When 1644 isn't enough, we can stitch 1138, 1139, 5156, and 1644 into one story. So if you're on a Windows box, right? I was on a Linux box, but if you are on a Windows box, these are bonus events that you might get. You might get Sysmon, you might get PowerShell, you might get 4688, but really it's this chain that tells the story. Okay, so now we're going to get into LDAP nom-nom, which was also very interesting because we're going to go the route of CLDAP, right? And LDAP nom-nom was designed to be stealthy, such as ADWS, right? Using just another tool in the tool belt, another method. But this is something that the defender has to be aware of, right? So regular LDAP search is going to fire that 1644. LDAP ping, which LDAP nom-nom is based on, 1644 will never fire. So what do you do now about this? It doesn't do that. It uses anonymous. How do you, as the attacker, or sorry, as the defender, how do you really capture that and understand that? So what we can do is we can use a different resource, the netlogon.log. Enabled with NLTest and your debug flags, the netlogon.log is going to see a lot more actually than the attacker is going to see, and you'll see that in the demo. So here, as I did it, right, the defender will see that mail slot is being hit, and we'll see various types of responses, whether that's a SAM login name response X or the SAM username is unknown EX. And so the attacker is not going to see. There's three of those. Is not going to see, right? Accounts enabled, accounts that don't exist, and accounts that disabled. So this is one place where, for this technique, the defender actually has the advantage. Always follow the code. You know that the README said no Windows logs are there. Wrong. In my case, again, we can use 5156 chained with the netlogon.log, and that is one of the events that just keeps on giving. It's one of my favorite events. So another key piece with this, right, is just another little sort of, benefit or tool in the defender's tool belt is using honey tokens with honey accounts. And so if the attacker, they're enumerating everything, you can put those in there as well as watch netlogon.log, and you can catch the attacker. So this is one extra benefit of adding in a little base of the honey tokens. So we can use LDAP nom nom. So let's now do a live demo and get some more fun. All right, going into our Kali box. Got some notes here. I've already enabled NLTest and already set the audit poll it should be on the domain controller. That's a key thing. The GPO could overwrite that. But what we want to do is we want to take our LDAP nom nom command. If I can grab it all. Well, I missed the E, but that's okay. And we can run that against our list of usernames. So on the attacker side, this is all they're going to see. Now, this usernames file could have 100, 400,000, whatever. This is what they see on the attacker side. So there's really no indication of just who is enabled, what's a honey token, or whatever the case is. We've gotten our results. Now, a tool that I wrote for the blog post was using a CLDAP, was trying to use it the same way, but I really wanted to use UDP as well, because this will take this takes the route of TCP. But just doing it a different way, just for sake. So this was kind of a tool I wanted to write and just kind of understand a little bit more to help, maybe on the offensive side. But you can see there that we'll use our enumerate anonymously via our root DSE and pull all the information back. We can get a variety of different information. And now you can see the responses a little bit more on the attacker side. And we've also used UDP there, but netlogon will still be benefit. So you can see those responses, right? SAM username is unknown, SAM logon response, EX, etc. And on the defender side, we actually have our tool. Again, I went ahead and enabled all the logs, but you can definitely see the alerting now of what the defender is going to see. They've hit our critical honey token a couple times. They also have hit more usernames LDAP Nom Nom didn't see all the names, but we had other people within the Sopranos cast. But what I wanted with the other tool was to get all the names and all the responses. But this shows that they actually hit those in the process. All right. This section, this is starting of the final arc. And this was very, very interesting for me. I want to tell just a little bit about myself. I am not a statistician. Math was never my strong suit. In university, I probably got a C, if that. I was more into political science. I was more into computers. I was more into government and criminal justice. I never really understood math, okay? So doing this, but I had this idea. I had this hypothesis, okay, in my head, which I'll get to in a second. We just want to remember some of our pre-flights here is using our turning on our diagnostic log, but what now is really going to come into play is some of these other fields that you set, right? The thresholds. And this is where volume-based detection is going to take place. When defenders hear the word volume-based detection around Bloodhound, Sharphound, they think of the session-side collection. They think of one box, on the network, reaching out to all these other boxes. 5145 is going to hit, accessing a share, and you're just going to have all this volume base. But again, that is the session collection side of Bloodhound. We're focused on that DC only side, right? Pulling back LDAP. So this is a little bit of a performance, just a reminder. You start at these volumes, you can get more aggressive. Everyone's sort of, tolerance is going to vary. But I have not really, again, seen any problems. Not to say they don't exist, but it's just something to be careful of. And just going back a little bit before we really start to get into this section, we've had 4 chapters, basically a whack-a-mole, right? A whack-a-mole-based approach, because they can change up anything. They can do anything. They can use other attributes, or they can, just do whatever they want. So again, my hypothesis, which we'll get into, and I understood that attackers need the data. They're getting that data. If they get that data, could we find some sort of pattern, some sort of deviation based on volume-based detection? And what I understand is, they enumerate users, they enumerate computers, they enumerate groups, and they're going to read all these attributes per object. So the hypothesis really was, if I know my environment, let's say hypothetically, that I have X amount of users, X amount of computers, X amount of groups, X amount of SPNs, X amount of ADCS, I understand my environment. My environment is my own baseline. I own my environment. And I kind of assume, or I've done some advanced work, that each object has X number of attributes, right? A user might have 23. A computer has 31. Could I now use that to create this hypothesis and use statistics and saying, if there's a deviation that's really, really, really high of what's being requested and returned, could we now try to catch the attacker through volume-based detection, true volume-based detection? So just dialing it back a little bit, 1644 tells the story of the 5 Ws, who made the query, what they're after, when did it happen, where are they looking, why does it matter, and how they're doing it. And some of these other things now within our log are going to become a key factor, such as indexes, or where are they searching. Again, visited and return pages that you'll see. So we're going deeper into the log itself. And this was part of, I think, the key secret weapon to 1644, was understanding the use indexes, understanding the index that was actually used, but the entries returned and visited here. So again, what they got and what AD had to scan. There's a variety of different indexes within LDAP. And so what you could do is, if one is more sensitive than the other, could you assign some sort of weight and measurement around that and saying, okay, service principal name index is going to be really, really critical, right? Because they're going to be enumerating those SPNs. Some of the other indexes, we could also assign a sort of a weight and measurement, such as high, medium, etc. So again, the environment is the baseline. Everyone's environment is different. You could have an SMB, 200 users. You can have mid, 5,000 users. You can have 50,000 users. But your environment is your baseline. Always a key part in any detection engineering is understanding the environment. Building the baseline. So we can build the baseline. Here, we can kind of do it live, but what you could do is you can establish a baseline of 24 to 48 hours. We can get our data point, exclusions, of course, scope, window, and then we could try to build our detections around it as well. So, yeah, I'm not going to lie, right? Did I use a little bit of AI to help me with my math and hypothesis? Yeah, sure I did, right? I have these ideas, and I want AI to really help me execute. I want to take it from 0 to 50. But you know what? That's the beauty of these days in the world that we're living in is, you can get the help, especially where needed. So this is kind of sort of the formula that's behind it. The blog post that has not been released is crazy long. I was like, how can I summarize this so even I understand of what's really happening? And it is kind of true. It is true. What just happened is X. We have our number of entries visited. We're going to have what's normal, right? And then we're going to have our wobble, so to speak. And you'll see this on the back end. And if anyone is a statistics major, I'd love to talk offline about this. But what we can then do, like I said, is we're going to try to figure out what's weird. Again, deviation. We're always looking for that as an attacker. Building out just how we build out these scores using our weights and measurements. So this is sort of the path that we're going to try to take, right? Build from normal, watch what just happened, compute how weird is weird, and why. So what can happen, right, is this empirical rule, and we can return, sort of take all this information and then generate alert around it to interpret, right, for the detector and for them to then act on. And what you would see, right, is we can have this sort of outlier, right, when they touch all the objects in Active Directory and they do maybe a loop over it or whatnot. You can see, generally my environment has 12, 47, whatever, and then it just rams up with Bloodhound, as Bloodhound will go out and just grab everything. So let's do a demo. Clear, of course. Can I spell clear? So a little bit of a script that we wrote, right? Just to confirm a couple things, what I might want to do is just going into it. I want to just make sure and confirm that everything is being parsed correctly, that I have 1644 is enabled. So this is really just my own diagnostics checks. It's really helping me that 1644 is enabled again, but I'm just doing the due diligence, right? Before we do anything, right, let's just clear our event logs. Why not? Because I want to clear my logs, doing it live. I also want to clear any sort of alert history, just for right now, for the sake of this demo. I'm OK doing that. Again, we'll type yes. We'll go back. OK. So I did not get a chance to build a baseline, right? So am I eating my own dog food? Maybe, we'll see. But what we want to do is let's just do it in real time. That's the part. Let's do it in real time. OK. So we're looking on our domain controller. Let's pivot over to our, we don't need this anymore. Let's pivot over to our workstation. Let me make sure I always grab the right command. Well, we can just do // we'll cd into #. I just got it there. -C. DC only. Now we're going through it. Yeah, we'll have a little bit of an error, but don't worry about that. My ADCS lab is still okay. But I'll be able to prove once it's done on the host that we got everything. But we already are getting alerts because it is doing the enumeration regardless of what the error tells us, because we have everything. 432 objects were grabbed, and we've got everything, right? Let's go back. Let's check out in real-time monitoring. As you can see, our client is 10.01.20. We have a score. We have an efficiency. So how performant are we looking at? And we get all sorts of detection regions. High pages or object, SD flags were included. ADCS, PKI infrastructure was enumerated. Excessive attribution of, in this case, 70, 60 in a small lab. And we get a variety of different alerts. And further down, right, you can see here SAM account type query detected was also there as well. It's included. So you got to hit Control-C to stop it, unfortunately. But you know what? Let's just do one thing. Let's take a look at our alert analysis. And let's see. So if you want a different way of looking at the data, maybe you're an executive, let's look at it this way. 4 alerts, 4 critical. As you saw, the average efficiency of the queries was about 74%. We can go down and we can see, how is our detection efficacy lining up. A lot of signature-based, statistical-based as well. Our top 5 sources, we only have 1 source right now in our lab, 4 alerts, and we get a variety of different output, and we can understand our top detection patterns, right, from over here. SD flags, the ACL base hitting that NT security descriptor was obviously the highest, excessive attributes, SAM account type, et cetera, as we go down. And you can see just a little bit more of just what's happening right behind, under the hood regarding some of the math, really. You can assign a score, severity, efficiency, and just, I always need the why as a detection engineer. High pages, objects, SD flags were enumerated, et cetera. And you can there see the LDAP filter. And actually, I believe with this one, if we go back, to the main menu, let's generate a DFIR report for those differ professionals maybe in the room. And we've not really released this yet, or I've not released this yet. I specifically saved this just for troopers. Did I lose my... Maybe I lost my PowerShell script, but we can go back. Sorry about that. Oh. I'm on my domain controller, so I forget which user is where. And let me just grab it one time. A little bit of a bug that with this is that I need to make sure that the output of the files all go in the same place. I think that would be very, very helpful. I'm not sure how about opening the logs folder is working. So just a little bit of the same, but we're going to get a little bit of the more detailed analysis, right? So the reasoning behind this. So if I really want to understand what was happening, right, I can see the exact LDAP filter, the visited entries, 319, 192, high pages object, and we can go further down. This is just giving a little bit more detailed to maybe the differ person or whoever that might need it. And we can understand attack patterns. We can understand maybe some recommendations, forensic information, as well as hardening stuff. But we get a little bit more information that we did not get before. As you can see here, we get our prop. We pull back our 1644, and it will give you all the information as well, and some of our notes where we've hit the subtree, et cetera. So just to summarize that sort of section right there, there's these signals where the attacker they can't hide, right? Is the volume, the index, the efficiency, and the pages. And each one tells a story of how what the attacker is doing, but tells the story to the defender of, again, what the attacker did and where they are and how we can detect them. But what happens when the attacker tries to go quote unquote low and slow? So I worked a case, and it was a DC sync case. It was actually kind of interesting because what happened was with DC sync, right, you have this option in a packet. I'm not sure how many people use it, but within secrets dump, you can specify your own LDAP filter. So I said, give me just the domain admins. And I wanted to know, would that, if I did that with LDAP, supplying a specific LDAP filter, would it be logged? And since I was only pulling back maybe 4 domain admins, I actually didn't get a 1644. And I was like, well, that's kind of crazy. Why did I not get it? So this is me trying to test my own detections, trying to bypass my own detections, which is a key part and a key element. And so that really goes into, right, the chicken and the egg problem, but also the defender's fix. So the key there is really sort of making sure, right, with those thresholds that you set within the registry, if they're too high, something like this will go under the radar. If they're too low, right, you're getting more, but that's the process on the domain controller. So that's again, the chicken and the egg fix is what do you do? We don't, there's always trade-offs from the defender side. So 80 is the trees, right? You got to pick which one you want to watch. You can watch one. Do you scope everything? You can look at certain different types of partitions. Right, your base EN, what attackers get, and where you can hunt. 3 axes, thresholds, flight 1. So again, this is understanding, right, your thresholds of when you set those in the registry keys. So when recon is invisible, you try to catch the theft, right? So the recon of that LDAP detection, might have gotten bypassed, but hopefully we have our 4662 of DS replication legs to stand on. And so that's what we kind of have that defense in depth sort of mindset with the defender. So obfuscation is going to be our last section when you get into LDAP obfuscation. So Maladaptive was released at Black Hat by Daniel Bonahan, who did invoke obfuscation, invoked obfuscation, and another person, the name is escaping. If they happen to watch this, I deeply apologize. But what they understood was, could you obfuscate LDAP queries similar that an attacker can obfuscate PowerShell encoding commands or CMD? And the answer is yes. But what happens, right? And now, granted, they only released the detection pieces of the detection side. They never released the offensive tradecraft. Okay, so really I had to go in and reverse engineer the tool, but running it, I was very, very surprised what 1644 will actually see. When you have a variety of different sort of techniques, events 1644 might strip, it might normalize, it might log as is. So what do you do as the defender? Well, you've got to pull in from another source, and that's going to be ETW from the client side. So now we're going to chain client-side detections with our domain controller. So LDAP Mon ETW, fantastic, fantastic tool. Was written by a great friend of mine, Johnny Johnson. And so we can just run in one window. Right, so now we're logging with LDAP Mon here. He wrote this whole code. It's phenomenal, totally open source. And do I have? Okay, so what we'll do is we'll open, let's open another tab, or let's open another window. PowerShell. Yes, run as administrator. I actually really enjoy doing these live. So let's, we've got our tool running and we can stop it, right? So what I'm going to do is I'm going to run in LDAP adaptive tests. Oop. Sorry about that. That's fine. And we have all of our options here. So what we can do is show our test queries. So these are going to be the different types of queries that we're going to run. Let's make this a little bit bigger for everyone. Just a variety, like this is all going to be in my lab, or we're going to do this live as it is. But we're going to go through all these sort of different sort of obfuscation techniques. And a fun fact was Charlie had in his fork of PowerView, he had LDAP obfuscation sitting there for a long, long time. I don't know if anyone's ever pulled it, everyone's ever used it, but he's had obfuscation sitting there since he actually made that fork of PowerView back in the day. It's just that Daniel and his colleague took it to the next level in terms of what type of obfuscation techniques that you can do. Okay. So we'll go kind of quickly here, as I'm actually called for time, which is great. I didn't think about that. So what we'll do is we'll test all categories. Continue on. Oh, sorry. Of course. And you're going to see that I'm now executing the queries in my own lab with real data, right? I'm hitting the KRB TGT, I'm enumerating users, groups, whatever the case may be. I'm just shoveling all sorts of different attack techniques in a different way, right? So filter, so on and so forth. Go back here to our domain controller. And let's just see what our domain controller sees. And we'll get into our other side. And as you can see here on our domain controller, right, I have a script here that we'll be able to use. We can show raw, use whatever, but basically it will try to figure out what the attacker actually ran. Let me see here. Let's see. Oh, let's get event 1644 max events 50. Pulling back our 1644, right? We have all sorts of data, and we can see just going through the logs, what's really happening, right? Here's your filter with all the white spacing, as well as a variety of other techniques that are in here. But the main thing is, right, we want to also, could we change this, right? Could we change this to our client side? So let's try to do that kind of quickly. I know I'm running on time, will do. It wasn't actually not running LDAP Mon. Oh, maybe I needed to stop it. Well, that's always the live demo, right? Of with LDAP Mon, it has to. I think it has to the. Yeah, I'm running out of time. So it has to write to the LDAP logs on the client side. But we can take my word for it that it was working, but it is a little bit of a live demo. I'm happy to show it later on, but it does work with LDAP Mon. It will log to its own. Johnny has created its own channel for LDAP Mon operational. So as again, I'm running out of time here. I just want to summarize that these are all the 20 techniques, and we can go through them and understand what the DC will see. And so just lastly, going to try to go quickly. LDAP Mon by Johnny Johnson, client-side ETW will see the real query, and we can then write detections based on that, and we can chain them together. And that's really the talk here now is just, again, trying to summarize no single log source is complete. You really need 1644, event 5156, LDAP Mon, ETW, maybe your net logon .log. And currently, I've released 6 pieces. The other 7, 8, and 9 have not been released, but hopefully you got a sense of the demos and the tools specifically for Troopers. Just understanding the tools, signatures, behaviors, statistics, when to use what, avoid when, and just some take-home stuff. Again, is the logs are normalized all the way down to ADWS attribution isn't impossible. We've proved that. 1644, right? That's your stack, and we want to chain all 3. And that is the presentation. I hope everyone enjoyed it. Sorry for going quickly there.
Thanks so much, Andrew.
Thank you.
I value the live demos, I value the energy, and I feel bad about putting you under pressure at the end.
No, it's okay.
So, cool stuff.
Thank you for having me. It's my pleasure.
Thank you. No time for questions.
That's okay. I can take them.
With the next one.
Absolutely. It's my fault. I will take them.
This is Andrew. You know how to find him. Man.
Thank you so much. Thank you, sir.